Assalamu alaikum. So we'll come to the next part of the lecture where we'll solve example. So here simply we have a two quadrant chopper in which S1 and D1 act as a buck converter and S2 and D2 act as a boost converter. So we have here a two quadrant chopper is used to control the speed of a DC machine. The K phi is equal 0.1 volt per RPM. The switching frequency is 250 hertz. The armature resistance is 0.2 ohm. The supply voltage is equal 1 to 0 volt, and we assume that IA is ripple free, which means that the inductance is sufficiently high such that the current is ripple free, pure DC. And here we have two parts. The first one, for the buck converter, if the buck converter is operated to control the speed of the machine at n 400 rpm and the current 100 ampere, we need to draw the waveforms of the VA. This is the VA, IA and IS. We need to determine the duty cycle of the switch 1, T on of the switch 1, and we need to find the power developed by the motor, the power absorbed in the internal resistance of the motor, and the power from the supply. In the second part, for the boost converter, which is formed by S2 and D2, if they are operating for regenerative braking, and when the motor rotates at n equal to 350 rpm and the current was minus 100 ampere, we need to repeat the same, except that in the last one the power will be fed to the supply. So let's start answering. So the first thing here, at steady state, VA can be written to equal to EA plus IA RA. So this will equal K phi omega plus IA RA. Now let's see, K phi is given, N is given, and K phi actually is 0.1 volt per RPM, so this will be K phi N. So this is given, and the current is also given, and this one is given. So it's plug and play. So VA will equal to 0.1 multiplied by 400, which is the K phi multiplied by the N. Here you don't need to do the conversion because already K phi is given in 10 volt per RPM. So if we multiply it by the RPM, we get the back EMF. Plus the current is given 100 multiplied by the resistance, which is the 0.2 ohm. If we do the math, this will equal to 60 volt. So VA will equal a duty cycle multiplied by Vn. So simply from here we can calculate the duty cycle, which will equal to 60 over 120. So it's 1 over 2, and this actually is T on over the period T. Now the period T is given, it's 1 over FC, the switching frequency, so 1 over 250, and this will equal 4 millisecond. So this will give us that T on should equal to 2 milliseconds. So if we plot it here, now let's assume this is the VA. Let's assume this is the current IA, and let's assume this is the IS, the supply. So the period was 0.4, so let's assume that this is the T on, and this is the period. So this is another T on, let's say. So from 0 to 2 milliseconds of the T on, the voltage will equal to the supply voltage, so 1 to 0 volt. After that it will equal to 0, and this will repeat. So here this is T on, which equal to 2 milliseconds, and this is the period T, which equal to 4 milliseconds. Now IA is already given. It's assumed to be continuous and ripple free at 100 ampere. And the supply now, the supply voltage, the supply current. The supply current, when the switch is conducting, then the current will flow from the supply to the machine. When the switch D1 is conducting, then the current will freewheel via the switch, and there is no current flows from the supply. So this means that IS will take the IA shape only if the switch S1 is on, which is via the or through the T on. So this will be the supply current. So this is 100 ampere. So the supply current only flow through the switch S1, and there is no current flow if the diode is conducting. So now we are plotting the first part, which is the waveform, and here we are calculating the T on of the switch. Now we need to let's say to calculate the power developed by the machine. So the power developed in the machine is equal EA IA, and this is a piece of cake. It's 0.1 multiplied by 400 multiplied by 100, and this will equal to 4000 watt. Now the dissipated power through the resistance RA, so the power in the resistance will equal I square R, so this will equal 100 square multiplied by 0.2, so this is 2000 watt. And finally, in the motor action, we know that the power here, the power on the supply, will dissipate it as the power in the resistance, and the remaining power will be the power developed. So simply, if I add this one to this one, I will get the power supply, which will equal 6000 watt. Or someone will say that the power for the supply will equal V supply multiplied by I supply. This is given 120 multiplied by the average value of this one. This is the area, so it will be T on over T multiplied by this one. So it will be 1 over 2 multiplied by 100, and if we do the math, this will equal 6 kilowatt. Now, what about the second part, when the switch D2, S2 and D2 is acting as a buck converter? The speed was N350 RPM, and the current is minus 100. Here we are in the regenerative braking. So of part B, let's say. So the first thing at C state, the same thing. VA will equal to EA plus IA RA, so this will equal to 0.1 multiplied by 350 minus 100, because the current in the regenerative braking, multiply by 0.2, and this will equal to 15 volt. Now VA will equal 1 minus D multiplied by the V. So this means that 15 must equal 1 minus the T on of the switch 2 over T multiplied by 1 to 0. If we do the math, then the T on over T will equal to 7 over 8, which means that T on is equal to 7 over 8 multiplied by the period, which is the 4 millisecond, so this will be 3.5 millisecond. Now if we need to plot the waveforms, now this is the T, and we need to plot the VA and the current IA and the supply current IS. Now T on will be somewhere here if we assume that this is the period. Now if the switch is on, the voltage will equal to 0, and if the switch is off, the voltage will equal to supply voltage, and this will repeat itself. So here this is the T on, which is the 3.5, and this is the 4 millisecond, and here the value is 120 volt. Now the current is assumed a ripple free, so it will be minus 100. Now the same thing, the current will, the supply current here only will flow if the D2 is conducting. The current will feed back here. Huh? So simply it will be minus 100 here. So this value is minus 100, which is only will flows to the supply when the switch is off. So here, this from here to here, S2 is on. Here D2 is conducting. Here D2 is conducting. So now if we need to calculate the same thing, the power developed by the machine, so we can say the power developed is equal to EA IA, and this will equal to 0.1 multiplied by 350 multiplied by minus 100, so this will equal to minus 3.5 kilowatt. And here the minus for the power, meaning that this power is generated. The plus power, this means that the power is absorbed or delivered. Now the dissipated power all the time will be positive, of course. PR will equal to I square R, and this will equal 2 kilowatt. Now here the power flow is changing. The machine is developed the power. After that, part of the power will be dissipated across the resistance, so this is the PR. The remaining power will be fed to the supply, so this will be the PS. So simply here this means that P supply will equal 1.5 kilowatt, or if we need to calculate it, P supply will equal to I supply multiplied by V supply. Now I supply is the duty here, which is the 1 over 8. Remember that this one from here to here is 7 over 8 of the duty cycle. 7 over 8. So this actually is 1 over 8 of the duty cycle, 1 over 8. So if I need to calculate the average value, it will be 1 over 8 multiplied by 100 multiplied by 120, and this will be 1.5 kilowatt. Now why here I'm taking a plus sign for the current, not negative sign, although here I'm taking the negative sign, because simply we assume that the sense of the direction is in this sense, which is positive with respect to it, to the motor. So any current enter to a port is positive. So here the current is entering to the positive terminal of the supply. So with respect to supply, the current is positive. That's why here I'm writing it as a positive current. If this difficult to understand, simply restrict with the power flow. This is very easy to figure out the power arrangement. Thank you.